Alright guys, recording your homework 4-4. So we have 6 problems. We're using rational root theorem and Descartes' rule of signs to find the zeros of the function. Rational root theorem first. We're looking at number 1. I'm just going to erase each time. Number 1, our a sub naught is 1 and our a sub n is 6. So therefore our p values are plus or minus 1. Our q values are plus or minus 1, 2, 3, and 6. Those are our factors of 6. So our q over p possibilities are simply 1 over 1, 2 over 1, 3 over 1, and 6 over 1. So it's going to be 1, 2, 3, 6. Then we're going to bring in Descartes' rule of signs. So really quick, f of x is equal to x cubed plus 2x squared minus 5x minus 6. So no change, 1 change, no change. So we have one positive real root. F of negative x is going to be negative x cubed plus 2x squared plus 5x minus 6. Only the odd exponents change. There's a change, no change, 1. So we have 2 or 0 negative real roots. So we're going to go with the fact that we have one positive for sure, and we're going to find our first positive. So I'm going to bring in my exponents for f of x, 1, 2, negative 5, negative 6. So between 1, 2, 3, 6, there's no reason for me to mess around doing ones that don't work. So let's see here. Let's do 2. 2 is going to work. We have 2, 4, 8, 3, 6. Nothing's left over. So now we have 1, 4, and 3. So x equals 2 is one root. So now we found our one positive. There are no more positives. So now I've got to check negative 1, negative 2, negative 3, negative 6 to see if we have any negative real roots. So 1, 4, 3. Let's see, negative 1 is going to work. So we get negative 1, 3, negative 3, 0. So this means that's 1x plus 3 equals 0. So x equals negative 3 is our last root. So our 3 roots are x equals 2, x equals negative 1, x equals negative 3. All right, number 2. And please don't just be using this so you don't have to guess your own numbers over and over again. Number 2, I'm going to use the blank area up here so maybe you don't have to scroll. So number 2, our a sub naught, so this is number 2. A sub naught equals 1. A sub n is equal to 20. So our p is plus or minus 1. Our q is plus or minus 1, 2, 4, 5, 10, and 20. Those are all the factors of 20. So once again, since p is 1, our q over p is going to be plus or minus 1, 2, not 3, 4, 5, 10, 20. Descartes' rule of signs, I'm going to go ahead and rewrite number 2. F of x is equal to x cubed minus 5x squared minus 4x plus 20. Descartes' rule of signs doesn't care, by the way, if there's a gap. Descartes' rule of signs does not care if there is a gap. So yes change, no change, yes change. So 2 or 0 positive reals. F of negative x is equal to negative x cubed minus 5x squared plus 4x plus 20. Yeah. So no change, yes change, no change. So we have one negative real root. So let's start with find our negative. So our numbers, our coefficients are 1, negative 5, negative 4, 20. So let's find our one negative root. I'm going to go with negative 2. I don't know if that's going to work actually. We'll try it really quick. That makes negative 7, that makes 14, that makes 10, that makes negative 20. Oh, what do you know, it works. So I found my one negative root, it's negative 2. So I'm going to do it again. Now I'm going to try to find my 2 positive, but it could be 0 positives. I'm going to try what? It's either 1, 2, 4, 5, 10, or 20. Let's try 5. That makes 5, that makes negative 2, that makes negative 10. Oh my gosh, I'm on a roll. So this is 1x minus 2 equals 0. So I add 2 to both sides, and x is 2. And from my other two ones, x was 5 and x was negative 2. And there are my solutions to number 2. Number 3. Number 3, my a sub naught is 2. And my a sub n is 3. Still not terrible. So my p's are plus or minus 1 or 2. My q's are plus or minus 1 or 3. So my p over q, q over p, my mistake, is plus or minus 1, 1 half, 3, 3 halves. Remember, it's just each value of q over each value of p. Descartes' rule of signs. So I've got f of x equals 2x to the 4th minus x cubed minus 6x plus 3. So even though I'm missing an x squared, Descartes' rule of signs does not care about that, all right? So no change, no change, yes change. So I have one positive real root. F of negative x, only my odd exponents change. 2x to the 4th plus x cubed plus 6x plus 3. No changes, 0 negative real roots. Because there was no change, no change, no change. So out of this one, I only need to find the real zeros. So number 3 only has one positive real. There's something wrong. Ah ha ha. You guys didn't call me on it because you're not standing in my classroom. That changed from positive to negative right there. So this was 2 or 0. So there are 2 or 0 positive real roots, and there are no negatives. That means there are 2 or 4 imaginary roots on this one. Just want you guys to keep that in your head. 2 or 4 imaginary roots. We're only looking for the real ones right now. So let's go ahead and try to find our 2 positives if they exist on number 3. So I've got 2, negative 1. I've got to put my placeholder for synthetic division. Negative 6, 3. So I have 2x to the 4th minus 1x cubed plus 0x squareds minus 6x plus 3. So I need that. All right, so my options are 1, 1/2, 3, or 3 halves. 1, 1/2, 3, or 3 halves. Let's go with 3 halves. Why not? I don't know. I like the idea. So 3 halves times 2 is 3. 3 minus 1 is 2. 3 halves times 2 is 3. Whoop, not going to work because 3, when I add those, I'll get 3 times 3 halves. My first one that I messed up on. My first guess didn't work. All right, let's try 1 half. 1 half will work. So I get 1, 0, 0, 0, 0, negative 6, negative 3, 0. Oh, those worked out nice. So now I've got to use synthetic again. I've got 2, 0, 0, negative 6. This is the last one I've got to find. I just need to find this one positive. We're going to go with 1. Get 2, 2, 2, 2. Oop, that didn't work. I need it to grow. So it can't be 1. It must be 3 halves. Nope, 3 halves didn't work already. Is it 1 half again? No, 1 half will make it shrink. Is it 3? That doesn't make sense. 2, 2, 6. Nope, that's not going to work. So I'm wrong here. What's the... All right, so I went through every option. Right, we did 1, 1 half, 3, and 3 halves. None of those work. So 1 half is our positive real root. X equals some other positive real number. It's not rational. It's not rational. Remember, the rational root theorem states that if rational roots exist, they are one of those. So this is going to be some irrational number. And then our other two solutions, because this is an x to the 4th function, the other two solutions are both not real. So they're going to be imaginary solutions. And that's it for number 3. Number 4. We have x cubed. So in number 4, number 4, a sub naught is 1, a sub n is 6. So once again, our p is plus or minus 1, our q is plus or minus 1, 2, 3, 6. So our p, q over p is just going to be our q values because they're all just divided by 1. Plus or minus 1, 2, 3, 6. Descartes' rule of signs, copying number 4 over. F of x is equal to x cubed minus 7x minus 6. No change, no change, so no positive real roots. F of negative x is equal to negative x cubed plus 7x. Ooh, I did it again. That x cubed has a positive 1 in front of it, so that one did change. So we have 1 positive real root. F of negative x is negative x cubed plus 7x minus 6, so we have a change and a change. So we have 2 or 0 negative real roots. Okay, now let's find them. Don't forget our placeholders. We don't have a squared value, so we need a placeholder for that. So we have 1, 0, negative 7, negative 6. We've got 1 positive, so let's find that 1 positive real root. It's either 1, 2, 3, or 6. Looks like it's going to be 2. Let's see. We'll get... No, it's not. It's going to be 3. All right, so there's our positive is x equals 3. Let's find either 2 or 0 negative real roots. Let's try them. Move this over a little bit. 1, 3, 2. Negative 1 is going to work. So 1x plus 2 equals 0, so x equals negative 2, x equals negative 1, and x equals 3. There are our 3 roots for number 4. F of x equals 10x cubed minus 17x squared minus 7x plus 2, no gaps. So our p is 10. Now our p, our a sub naught. Our a sub n is 2. So our p, my apologies, are plus or minus 1, 2, 5, 10. And our q are plus or minus 1, 2. This is going to be one with a lot of options. So our q over p's. It's going to be 1 over 1, which is 1, 1 over 2, 1 over 5, and 1 over 10. Then it's going to be 2 over 1. So I'm doing this one now. 2 over 1, 2 over 2, 2 over 5, so on and so forth. So 2 over 1 is 2. 2 over 2 is 1. I've already got 1 written, but I'll go ahead. So we have 2 over 1, 2 over 2. Let me do that. 2 over 1, 2 over 2, 2 over 5, and 2 over 10. So rewrite our q over p's really quick. 1. 1 half. I use that one. Use that one. 1/5. I use that one. 1/10. 2. 2 over 2 is 1. I've already got 1 on the board, so I don't need to write it again. 2 over 5. And 2 over 10 reduces to 1 over 5, and I've already got that on the board also. So those are my options for q over p. Descartes' rule of signs. F of x equals 10x cubed minus 17x squared minus 7x plus 2. Yes, I changed. No, I didn't. Yes, I did. 2 or 0 positive real roots. F of negative x is going to be negative 10x cubed minus 17x squared plus 7x plus 2. No change. Yes, change. No change. So 1 negative. That's the one we'll focus on first. 1 negative real root. Our coefficients, no gaps, 10, negative 17, negative 7, 2. Let's try 2. I'm feeling 2. 20, 3, 6, negative 1, negative 2. Yeah, it worked. So I found I found a positive. I didn't mean to go with positives. Oh well. So that means there's another positive at least. So let's go ahead and find that one. So we're working with 10, 3, negative 1. Let's go with, what's our other positive going to be? Let's go with 1/2. Half of 10 is 5. Nope, that's not going to work. Too big. Let's go with 1/5. 1/5 of 10 is 2. 3 plus 2 is 5. 1/5 of 5 is 1. Great. So x equals 2 and x equals 1/5. And now we've got 10x plus 5 equals 0. So that means we're going to subtract 5 and divide by 10. 10x equals negative 5, divide by 10. And x is negative 1/2. There's our last one. Before that, we had x is positive 1/5, and we have x is 2. There are our solutions for number 5. If you guys are wondering, I don't circle the whole thing because it'd probably delete what I copied over so I can see the actual problems. Let's get 6 done and be done. Rational root theorem. So our P on number 6, not our P, our A sub n, A sub naught is 1. Our A sub n is 4. So our P is plus or minus 1. Our Q plus or minus 1, 2, and 4. So our Q over P is plus or minus 1, 2, or 4, because it's always nice when our P is just 1. F of x equals Descartes' rule of signs time x to the 4th minus 5x squared plus 4. Everything's even. This is an even function. Note that. So we have a change here. We have a change here. There are 2 or 0 positive real roots. F of negative x. The reason I said note that it's even. F of negative x is going to do nothing. My even powers don't change. So it's the exact same equation. So there is a change. There is a change. 2 or 0 negative real roots. Let's see which ones they are, if any, because we could have 0 positive, 0 negative, and we could just end up with all imaginary. But we got to try. Don't forget our gaps. We have 2 gaps. We don't have an x cubed, and we don't have a just x. So we've got 1, 0, negative 5, 0, 4. 1. Let's go with, so we've got 1, 2, or 4. We're doing positives. Let's try 1. Should work out. We have 1 times 1 is 1, plus is 1. Is 1, is negative 4, is negative 4, is negative 4, is negative 4. Fantastic. So 1 is one of our positive real roots. Let's try to find our other positive real root. 1, 1, negative 4, negative 4. Let's see here. 2? Let's go with 2. 2. Well, that's a 1 right there, sorry. 2, 3, 6, yeah, I think so. 2, 2, 3, 6, 2, 4. Yay, x equals 1, x equals 2. Those are 2 of our roots. Now we've got to check to see if there are any negative roots. So we're going to check our negative numbers off of 1, 3, 2. Let's try negative 1. Negative 1, 2. Negative 2, 0. Yay, so negative 1 is one of them. So here we have 1x plus 2 is equal to 0. Subtract 2 to both sides. We get x is negative 2. We before that had x is negative 1. Before that we had x is positive 2 and x is positive 1. There are our 4 solutions and our homework is done. See you tomorrow. Have a great night.